Hi everyone and welcome to session 22 of our CATIA series. Today is all about the chamfer tool. From manufacturing standards to advanced hole cares, we are covering it all. Let's jump into the software.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate. Every line precise and true. Colors bright and brand new. Transforming steel into art. CATIA plays the perfect part.
Hello everyone, welcome to 22 lesson. This is the Mikebaba-CATIA channel. Today we will learn the chamfer tool. This tool looks very simple, but it is vital for industrial design. You already use it in the sketcher. Experience has shown that CATIA is more effective at chamfering complex three-dimensional shapes. In 3D, chamfer is a dress-up feature. It is directly linked to manufacturing. Assume we have a cube like this. We want to make a chamfer one of its edges. First, activate the tool. The chamfer definition window opens. The settings window of this tool has two main sections and 7 subsections. First subsection is mode. I click the V symbol in the box next to it. There are 6 different modes here. The default mode is length/angle. This is the standard method in drafting. First, pay attention to this question. In chamfering, is the edge important or the surface? Chamfer is inherently an edge-oriented operation, but its result is entirely dependent on the side surfaces of the selected edge. From a selection point of view, we select the edge. The chamfer is defined on the edge. A chamfer without an edge has no meaning at all. From a geometric point of view, the surfaces are decisive. A chamfer creates a new surface that is placed between the two previous surfaces. If one of the surfaces has a problem, for example, an inappropriate angle or lack of continuity, the chamfer becomes misshapen or is not created at all. Now listen to a very key point. It is called the reference face. Length 1 is always measured on the reference face. When you select an edge, CATIA picks a face. you will see an orange arrow. This arrow shows the direction of the chamfer. In this mode, the software creates an imaginary line on the reference surface in the direction of arrow. From the end of this imaginary line, another line is drawn at a specified angle towards the adjacent surface. Wherever this line intersects the horizontal surface of the part, a line is drawn from there to the starting point of the vertical line. In this way, a triangle is created. You will see the shape of the triangle in green. Now this triangle is subtracted from the edge of the cuboid. We can select multiple edges together. If we want to remove or add these edges, we have to go to the Objects to Chamfer box. Click on the Selection List icon. It looks like a small list. Here you can remove or replace edges. You don't need to close the command. Now we have a cube with one vertical corner rounded. Next is the propagation section. This is how the chamfer spreads. Tangency mode is the first option. It follows all edges that are tangent to the selected edge. It creates a continuous path. Minimal mode is the second option. It stays only on the edge you selected. It does not spread to other edges. Suppose we have a such shape. We want to chamfer 3 connected edges at a corner. First, I activate the command. Let the mode in sections mode be length 1 angle. I give length 1 a value of 25. The angle should remain 45 degrees. In the Object to Chamfer section, I select the three edges. I set the propagation mode to tangency. I click on the OK button. You can see that the three edges have created a triangular shaped chamfer at their intersection point. I press the Ctrl+Z key combination. I activate the command again. I select the three edges with the same previous settings. There is an option called Chamfer Corner in the Settings window. Now this option is active. I will deactivate it. I click OK. You can see the result. Now the triangle has turned into a star. I press the Ctrl+Z key combination to go back to the initial state. I activate the tool. I click on the More button to open the second section of the Tool Settings window. You can see that there is an option called Chamfer Corner in it. This is for corners where three edges meet. With the Chamfer Corner option enabled, we can only select the corner points. Now the text No Selection is written inside the box. I click inside it to make the box blue. I move to one of the corner points of the shape. When the point is highlighted, I click. The text setback distance is written inside the box below this option. Inside the box in front of it, you can see the number 10 mm. This means that the software will go back 10 mm on each edge from the selected point and create the chamfer. The value of 10 mm is shown on the shape. I click OK. The result is visible. Note that this option only bevels corners. This is great for safe mold making. Note that when you see this option, the options in the first section are inactive. I activate the command again. In the mode section, I select the second mode. In this mode, we have to give a value for both sides of the chamfer. At the bottom of the window, you can see an option called Symmetric Extent. If this option is active, the length of the chamfer on both sides will be symmetrical. In this case, only length 1 is active. If this option is not active, the length of the chamfer on both sides can be different. Now let's discuss chordal length. This is a specialty of CATIA. It is used in the car body industry. When the angle of two surfaces changes, the visual width of a typical chamfer is ugly and variable. In this mode, the chord length stays constant. Assume we have a cube with rounded edges. First, I use length 1 angle mode with length equal 10 mm. You see the result. Now I change the mode to chordal length. It is seen that a more uniform chamfer was produced. The fourth mode is height angle. After selecting this mode, first pay attention to its settings window. Three important options in it are height, angle, and object to chamfer. First, you must select the edge that you want to chamfer. Second, you specify the height value. Third, you determine the chamfer angle. Now, the method of determining the chamfer value in this mode is as follows. The software draws a line from the selected edge at a supplementary angle to the given angle relative to the reference face with the length specified in the height box. From the end of the line, it draws a perpendicular line in two directions. Wherever it intersects the two surfaces of the object, it considers them as the cutting edges. Finally, we have hole curve. This takes chamfering to an advanced level. You can make a variable width chamfer. It follows a specific sketch or curve. This is perfect for ergonomics and styling. Now we explore the advanced modes of this tool called whole curve angle and whole curve length. I'm showing you three shapes. The first shape is a cube that has a curved groove near one of its edges. I activate the chamfer command. I set the first option mode to whole curve angle. Now the box in front of the object to chamfer option is blue. I must introduce an edge to the software. I click on the edge next to the groove. The name of the edge is registered in this options box. Now I click in the box in front of the whole curve option so it turns blue. I click on the edge of the curve groove. Here you must pay attention, select the curved edge that is closer to the edge we want to chamfer. If you select the opposite edge of it, after clicking the preview button, you will encounter an error. I will remove this edge. Now I click on the appropriate edge. I press the preview button. I press the OK button. Look at a chamfer was created in the shape of the existing grooves curve from the grooves edge with a 45-degree angle. Now you understand why the software did not accept the previous edge. Now we have a similar shape, this time with a straight groove. I activate the command again. I set the mode to whole curve angle. First, I click inside the whole curve box. I want to show that the selection order of the boxes is not important. I select the edge of the groove. Now I click in the object to chamfer box. I select the two opposite edges of the cube. I press the preview button. Again I encounter an error message. I click OK on this message. Now I remove inappropriate edge. You can see that a chamfer was applied from the groove's edge to the cube's edge at a 45 angle toward the vertical side. Note, the edges of the grooves must definitely be located on one of the chamfer planes. Note, if instead of groove's edge, a curve or a line fully constrained on the surface was selected, the software would not allow us to select it. I will show you this case. Now consider the last shape, a cube with rounded edges that we have hollowed out. We want to chamfer from the inner edge toward the outside. Look, if we use other commands, starting the chamfer exactly from the inner edge might become very difficult or impossible. Important points to keep in mind about hole curve. This mode is excellent for connecting several surfaces, variable chamfers, and mold parts. The models you saw were all related to using internal curves. My advice as your teacher: always check the orange arrow first. This avoids mistakes on the reference face. Chamfering is not just for beauty. It removes dangerous burrs. It also makes part assembly much easier. Thank you for joining this session. Practice the Chordal mode today. Watch this video again. Try it on complex parts. I wish you success. See you in the next lesson.
Let's build the future. Come with me.